we can look at a device that have some more information that is there, so we do update that also. And again, we load the data from the web server, and we see the clear text here. This node is zeroed out. In this case, it's a test node, and the MDF URL is different here. It's this is a smart Kelvin smart node for temperature. We saw it, and the rest is quite the same. In clear text, it's Kelvin smart 2 node. Also reversion 2, and it's been changed recently, and we can read all about it here. It's from Eurosource here in Sweden. Make it, and we have all the contact information for that company here. And the same again here. We see the registers, zone, subzone. We see the temperature here in hexadecimal. It's 9 cc hexadecimal. You can see if this changes. Yeah, C8 instead. You see, but no change now. But you can change. We see some other data, and again the standard values here. I see the UID and the URL. This node has some abstractions defined for it, and it can work with 2 temperature sensors, is 1 and 2, and here we see the data as a 16-bit number, signed 16-bit number, and we have a problem here. I don't know, we have no sensor on sensor 2, that's why we have that value. And you see high temperature for sensor 1, accumulated high temperature and accumulated low temperature sensor, and mean values are also recorded. This module doesn't have a decision matrix either, so we can look at module 3 that does, and we do update again and check what information we can gather from it. And now we read all the register pages from it then. So this is a read of 256 bytes. Downloading the MDF from the server again. And again we see the Eurosource. This is actually a test module, not a real thing. And if you look at the UID, it's have a different form. It's node DD3. We can look at the real data. Here is VSCP RVR 8090 CAN 128 test module, and module A and version 3, and okay, you see it all. Again, no abstraction on this one, but we have decision matrix, and what we see on the decision matrix is we have a originating address, and in this case it sets to 5A hexadecimal. We have some flags. We have a class mask, a class filter, a type mask, and type filter, and an action that the module should perform when all these conditions are fulfilled, and some parameter for the action. Why do we use the mask and the filter here? The answer is that we want one condition here to be able to trigger from more than one event, and we can fulfill that with this. To edit a row here, we just double click on it, and you see the 5A here is going into to decimal, and we have a much nicer form we can work with. And if we look at the flags, we can enable the decision matrix row. We can click in this so the originating address is checked, and we can say that it should be hard coded, and the zone should match ours and subzone should match ours, and we can set class and filter, and this can be time consuming to calculate by hand, so it's a visit for it. If we want class protocol read register like that, we add it, and if we also want write register to trigger this, we add it, and all this will be calculated for us. The action is here in clear text, also fetched from the MDF file on the server. And this module can do three things. Nothing. Control LEDs, that is, light some LEDs, or write something to a serial channel. So control LEDs. And if we says this should be 2, it will lit LED number the second LED. So just click OK, and it's written out the module, and it works like this. So some other things coming up here are decision matrix setup wizard. Same here, it will be a wizard to set up a module in a more user-friendly way, where you don't see registers and where abstractions will be used in first. So if there is an abstraction for some registers or register pairs or register groups, that will be used first. But if the register that doesn't have an abstraction, then the register will be used and the register information. That's it for now. I hope it clarified some things at least. Okay, bye.